first things we talked about in here this school year was the slope stuff. You guys don't have to have your laptops out right now. We're doing notes. So slope stuff, remember, is the change in y or the change in x. And you guys, bless you. What was happening a lot of times, and I even had people ask me this today, oh, that's the equation for slope? I'm like, yeah, we've been working on the same equation for a week. Should not think to say that beforehand.
Are we going over the same unit again?
Yeah.
Then are we got my notes?
What's that?
Yeah, I got my
taken
notes
all these
down.
things. So should we just take them again?
Yeah, it'd be a good idea.
Okay.
Because too many people aren't looking at notes, they aren't looking at anything. I get it. You know, I know we've done this, and I'm trying not to, beat a dead horse here, but trying to help everybody out. When you're doing these things, when we're setting these things through, if we do stuff like this, and you're given a set of order pairs, and we're writing all this stuff out, and you need, let's say you need to write the equation of the line into that slope-intercept form. Well, this was one of the very first questions that we did this whole school year. And it started out by the first thing having to do is find the slope. Well, when you write out the equation for slope, it tells you what values go where. The only thing that you have to do then is decide which value is which. And I know that all of you have worked with this before, but remember, and I know we've done this before, the more you label your information, the more stuff you have there, the easier it becomes for you. Because now you have the equation and you have everything labeled. You just substitute in what goes where. And it's a matter of pressing buttons then. We know that this problem then becomes -4 minus 0, -7 minus 1. And I've said this also with the calculator stuff. I know this isn't the exact same one, but this one also has that fraction bar. When you have the calculator with that fraction bar, it makes your life easier because you can type in exactly what you see and nothing changes. It does all the simplifying of it for you. It does the fraction work for you. It does the signs. It does everything by using the fraction bar. Okay? If your calculator doesn't have a fraction bar, stop in sometime and I'll show you how to use it with parentheses. But the problem then becomes you'll have to know how to simplify your own fractions or how to convert decimals back and forth. This is why we keep saying that multi-view calculator is perfect. It's absolutely perfect for this class. Okay? So in this case here, it gives us what, a slope of 1/2. Now, when you did that, then you had to write out the equation into the slope-intercept. But in between that, there was another little step. That's when you used this. Point slope. Point slope is the super easy, it's kind of like the working version of slope-intercept. Because now you have a slope and pick one of the points. And it doesn't matter which one you choose. You're going to get, theoretically, you should get the exact same answer for both. Sometimes one set of ordered pairs is easier than the other. Which one do you think might be easier? The one with the 0. The one with the 0. Because adding or subtracting with 0 is pretty easy. And you've got everything labeled right away. Send it to both parts. What's half of -1? words, yes. Sending it through. Now, I think we've had some of the ones with fractions that had a little bit weirder of denominators. But remember, it's nothing to be worried about. I think we had to do we've done a multiplying before, was what, -5 thirds. I think it was times an 8. Remember, when you multiply fractions to whole numbers, all you're doing is multiplying straight across. That's it. Or you press buttons with the fraction bar on the calculator, and it does it for you. You never have to worry about it. You shouldn't. The arithmetic of these should never be wrong because you've got that calculator. The other thing that happened that a lot of people had forgotten about was when we did, let me write down the problem. This one. We had one like that, where you're solving for the missing value, where you're writing things out. You're given a slope, one ordered pair, and one of the other coordinates. What's the missing value in the ordered pairs? I think a lot of times when people got this style of the quiz question wrong, is that you guys were trying to write an equation that was parallel. Never said that. It said find the missing coordinate. So it's the idea of making sure we go back and double check what we're reading about, what are we trying to do, and go from there. If you have the slope and the 2 points, I need you to stay awake. I need you to stay awake. Okay? Why don't you stand up and walk around with me? You can take notes while you're standing. I mean, I'm just trying to come up with a solution to this because I need you to stay awake. Otherwise, I'm gonna let her just start beating you. Beat them over. Do you want to beat them?
Sure.
All right. If you see the head bob, what are you allowed to do? You can do it. All right. Anyway, write out the equation here, guys. When you have this, if you think about when you're trying to find a slope, it has 5 parts to it. 5 variables, if you will. You know 4 of them. And again, all we're going to do is label. We're going to label and use direct substitution. Okay? We label and go direct substitution. First x value, first y value, second x value, second y value. There's all 5 of them are now labeled. It's a matter of just putting it all together. 1/3 is 0 minus -4. X minus -7. Do me a huge favor. When you get to these types of to this point in any style problem where you happen to have minus negatives, take 5 seconds and rewrite it. Simplify it first. Don't try and do stuff when it's written like that. A lot of times when you guys see those double negative things, you tend to screw up. You try to move things around. Just simplify it. I know there's no button in the calculator that you can do x minus a -7, but we know that 0 minus a -4, if I type that in, what do you get? You get 4. So this means that the denominator also becomes x plus 7. So take a second and just rewrite it. Now we have the good old-fashioned fraction equal fraction. How do you set up and solve fraction equal fraction? Cross multiply. What's 3 times 4? 12. Cross multiply it. One times all of that doesn't change what's in the parentheses, does it? Nope. Just rewrite it. And we were talking about this in 4th hour. This now becomes the exact same problem that you guys saw in 1st grade. I know every single one of you guys had that problem in 1st grade. It's the same thing, isn't it? What plus 7 is 12? 5. You just did it back then in your heads. Just count up real quick. It's the same thing. You were solving algebra problems before you even knew that algebra existed. Okay? You were doing that. And that's all it was. Notice, I didn't try to write an equation, I didn't try to do anything, I just solved the missing value because that's what the instructions said. I wasn't trying to go and do extra stuff. Okay? That was one of the main things that people started messing around with quite often on that. And then we go back to the what kind of happened to the front page. The parallel and the perpendicular equations. And when we talked about this stuff again today with the other 2 classes, they started to realize that they were making it tougher on themselves. They were trying to think that it was harder than it was because they were doing more work than they needed to. They were coming up with stuff that didn't need to happen. For example, we'll say this is, remember, instructions will always tell you whether it's going to be a parallel or perpendicular. You just have to remember what to do with the slopes. So if I have the point 6, -1, the equation y equals 3x plus 3/4, and I want to write the equation that's parallel. Really, in essence, we just have to go through the steps. And remember, we wrote these out a lot. Your first step was always to figure out what the original slope was. Now, some of you guys are writing down the actual 3 steps and going through them as you're doing it, and that's great. Do that. If you're not doing that, start doing that. It's one of those ways that kind of keeps your head in the game of what to do when and what to do next. And that's like the progression of the problem, the how-to. I cannot eat. Thanks. The original slope, in this case, remember, is y, first you should ask, is y by itself in the original equation? Yeah. So it's in that slope-intercept form. It's in the y equals mx plus b. What's your slope? 3. So you write it down. The original slope's 3. This is a parallel problem. What's parallel to a slope of 3? 3. And now you have your slope and that point. Hey, that looks like point slope. And again, you're back at substituting in. You have all the info you need. And go in there. How should I rewrite a minus -1? All right. I'm going to rewrite that before I do anything else. Because a lot of times you guys try to move the negative and you wind up messing up the sign. Did I take this 6 and -1 and fill in this other x and y with 3 and the 3/4 or anything in here? No. So Don't do that. A lot of you guys were. I actually legitimately saw answers like this. Because people were just putting in all the numbers. We never did anything like that. So don't do that. What do you do with the 3? Distribute, multiply it out. Some of you guys are drawing your arrows. Great. Keep it up. And now I subtract the 1. Don't mess up the simple math here. I saw a lot of people writing -18 minus 1, and you would write -17 because you subtracted. You're going more negative, so it becomes -19. Press the button on the calculator, okay? I know a lot of you guys probably think, oh yeah, I'll get it right, I'll get it, it's all right. Oh, here's the calculator. You haven't done math for a couple of months. Let your brains come back to it, okay? That's the kind of setup that we go through. We take our time to make sure it works itself through, okay? It's the little stuff like that. This is the subtlety of just setting up a problem. We brought the analogy, how many of you guys are taking like a foreign language? And then when you're in foreign language stuff, you can learn all the vocab you want, but it's how you put it together, the structure, the accents, the way that the words blend together sometimes. That's the subtlety of learning a different language. Math is a different language. There are certain subtleties to it that allow you to move things around. It's like putting that minus and negative and change to plus. It's a subtle trick. You don't need to, but it makes life easier. As you learn these little nuances, you get better at it. I mean, the more you take foreign language, I took 4 years of Spanish in high school. I still speak pretty decent Spanish because we taught, I mean, my last 2 years was just nothing but español, de clase, hora. And that's all we talked. And so you learn a lot from that. I mean, don't get me wrong, you don't remember all of it, but la puerta, la ventana, su reloj, los zapatos negros. But it's those little tricks that you learn, you pick up on, all right? When we were in Spanish in high school, we all tried to do that hola. We tried to sound cool. I mean, sound like a doofus. But it's the subtlety of it that makes me think about how I'm speaking it. So. The other one that we messed up a lot on was the. Yeah, I know. Something like this. We're going to do a perpendicular equation real quick. Obviously, just like we've done over and over again with a lot of this, the first step here was to identify the original slope. I can't do that right away, can I? What do you have to do? Yeah. A lot of you guys forgot that. Sometimes equations aren't automatically written as y by itself, so you have to do a little bit of work. We've had a couple of those like that throughout homeworks and stuff as well. You got to get rid of the 2. I'm not subtracting here, I'm dividing. Okay. So when I divide that out, y is all by itself then, and you get that. Now you have y by itself, you're able to identify the slope, which is say it with authority. Like question, you're not asking a question. It's not Jeopardy. So what's your original slope? It's it too. Actually, you know what I like about Jeopardy? When they have like the kids week, I usually do really well against the little kids. It's perpendicular because it said so. What's perpendicular to a slope of 2? Excuse me, negative 2.
Alpha 2?
Positive. Change it, flip it.
Half. 1 over 2.
Yeah. Change it, flip it. Opposite reciprocals. Change it, flip it. And now you have your points. Here's your first x, here's your first y. And it's a matter of direct substitution again, because everything's labeled. We start filling in the blanks. And what can I change? Yeah, exactly. And if seriously, if you're okay and you want to jump right into just writing it as x plus 4, go for it. I'm hoping to stop doing that soon. Now, again, we have a fraction, but is it a scary fraction? No. What's half of 4? 2. And then how do you move a negative? But what really concerned me a lot was when we got to what I thought was the easiest part of everything. When it came down to horizontal and vertical lines. Remember the analogy we kept going back to with the notebook paper? When you have a horizontal line, horizontal lines go what direction? They go left and right. Horizontal lines go left to right, and they all have the exact same slope. It's always y equal, or excuse me, the slope is always 0. The slope of every horizontal line is always 0, no matter what the equation of the line is. Because by it being horizontal, it's always going to have that same slope of 0, no matter what. Another way to remember the slope of a horizontal line, what's the second letter in the word horizontal?
0.
It looks a lot like a 0, doesn't it? It's a stupid way to remember it, but it works. Okay? So if I ask you what's the slope of a horizontal line, the answer would be 0. It's not y equals a number. That's the equation of it. And that's the other thing that they all have in common. It's always y equals some number. Okay. Excuse me. When you start looking at the vertical ones then, when you start talking about the vertical lines, yeah, I just realized that too. Standing on one foot. When you look at a vertical line, vertical lines all also share the exact same slope. They all have an undefined slope. The reason that it's an undefined slope is that if a horizontal line has a slope of 0, that's the exact same thing. Because I can divide it by 1 and it doesn't change it. The reciprocal of this would be 1 over 0. When 0 is down here, this is undefined. You get that error message on your calculator. You cannot divide anything by 0. Okay. Excuse me. I think you guys did stuff last year. Did you ever see anything like that last year? Some polynomial stuff like that? Where you would, if you had, then you would say x cannot equal positive 2, x cannot equal negative 4. Do you remember doing that? What's called excluded value? What you're doing here is you're figuring out where it becomes undefined in the denominator. When it becomes undefined in the denominator, if you were to graph this, which you'll do in Algebra 2, you get what's called a vertical asymptote. Vertical asymptotes all have the equation x equals something because it's a vertical line. That's why we try to keep bringing this back to saying vertical lines that are undefined. Okay? This will come up next year, but this is trying to show you why we have it as an x value. Why is it x and why does it go vertical? It's because we use it again later. Every one of these has the same equation, and it's always that. It's always that. What became really weird to me was that when we had questions, horizontal lines are always parallel to horizontal lines, and vertical lines are always parallel to vertical lines. It always baffled me that we struggle with that because you look at it every day. Each one of your papers that you guys have, I don't think everybody's using non-lined paper. It's all lined. And every time you write down like example number 1, example number 2, example number 3, whatever you're writing down, each one of those become parallel to one another. You've got really nice things. And by going through this, when you're writing equations, that means that a y equals something is always parallel to some other y equals a number. Always, always, always. So if we have the example parallel through point 3, 8 to the equation y equals negative 6, y equals negative 6 is a horizontal line. The reason it's a horizontal line is because it's y equals a number. All these lines are parallel to all these lines. All these lines have the same equation. They start with the letter y. Bless you. What's the y value in that ordered pair? 8. So parallel to y equals negative 6 has to be y equals 8. That's how that works. It is quite literally just pulling numbers off of understanding where do the equations go from, or where do they go from, how do they relate to one another. It is very, very verbatim. It works the same way with verticals. But what really was weird, when you guys had this. Horizontal lines are always y equals something. Vertical lines are always x equals something. They're perpendicular to one another, and they always will be. So if you know that, if you can at least remember that these are y equals and x equals, put them together, and this happens. So if you start out with an ordered pair, and that, x equals 4 is what kind? Horizontal or vertical? Vertical. Vertical is perpendicular to what? Horizontal. The equation of every horizontal is? What does y equal? 7. Yeah, doesn't it? Don't feel stupid.
y and x on the same side equal.
Then you just keep y by itself. All right, I know where you're good with that. Let me walk through one more of these real fast, okay? Y equals the number is horizontal or vertical? What's perpendicular to horizontal? What's the equation of vertical? X equals the number. What's x equals? 6. These are facts. Perpendicular to that is x equals 6. What's that? I hate to say it like this, but you probably, if I'm playing the law of averages, and it's not just you. Yes, ma'am. Oh, yeah. Thank you. I want to show you guys where the homework stuff's at. So, remember, guys, all this stuff that we were working on, these little shortcuts and stuff like that, they're meant to help you go through some of these types quicker. And I'm glad, I'm hoping that these guys are like, is this all this is? Get this bad thing out of the way. We'll do better on this on Thursday stuff. But I want to show you here real quick where we put the homework this time. Oop, let me publish this out. I'll show you where it goes. So this sheet is, obviously it's under geometry, chapter 3. And then you got to scroll to the bottom. 3.4, 3.5 writing equations. This is Tuesday's homework. I try to make it pretty obvious of where it was at. Click it, and I have you guys doing 6 through 24 evens. Now, what I have on here is some of the ones where you were asking about what happens when you have x and y on the same side, or you just got to get y by itself. So you'd have to move a couple of things. Now, on this sheet here, it's equations of the lines with a point and a slope. Solve for y. Points and slopes. And I've got a couple of parallel and perpendicular ones. Now, the answers are on here. And I wanted you guys to have the answers so that way you could go back and see if your work matches up. Okay? It doesn't mean write down the answers. It means show your work to get to the answers. And that's kind of how a lot of stuff works itself out, all right? Did that make sense on how we found it then?
Yes.
I just wanted, because it wasn't the same, like a little blurb tab or anything like that. It was an actual hyperlink that I just want to make sure it all opens up. And we'll go from there. Yes, ma'am.
So the lessons with that.
Yes. Can you come in next hour for flex?
Yes. And then
Perfect.
There's 3 papers.
That's fine.
But they're not stapled together though. But
Oh, I used to have a stapler up here. I gotta remember to get one. Yeah, that's all fine. That's fine. I was gonna ask if you want to leave your stuff here. If you just want to run back and forth, that's fine. Perfect. And I was gonna ask you before you left.
Well, my flex class is downstairs and they don't let us flex out, so like,
If you run down there real quick to show them that you're taking a quiz, and then just say, hey, I'm here, but I just want to use the time. You should be all right.
Okay.
They usually do that without a problem with people that have quizzes and stuff like that. They let them come up real quick.
This helps me a lot now.
I hope glad. I'm that's.
I'm trying to make me fall asleep. I kept them open.
The horizontal and vertical stuff make more sense on